Hello everyone, good morning. Am I audible? Okay, perfect. Okay, so let's begin with the session, guys. So what did we discuss in previous session here? Okay, in the previous session, we spoke about methods, then we spoke about method overloading, and we also understood how do we accept dynamic input from the user here, correct? So these were the few topics which we have covered in yesterday's session, and yesterday I had given a couple of assignments here, and I have received from majority of you all. Okay, and the rest of you all, if you are interested you can, or else you can ignore it. Okay, so it doesn't matter. Okay, anyway, so what is the topic which we are going to discuss in today's session? Okay, in today's session, we are getting into a very important topic, that is something called as static here. Okay, so we are supposed to talk about something called as static. What is this static? We are supposed to talk about it in a beautiful manner. Okay, so now here in today's session here, let us try to understand in detail. Okay, now here there are two types of variables as of now. One is static, another one is non-static. Okay, so let me just brief out the notes here. Okay, so here whenever we talk about static, right? Okay, whenever you talk about static, it's just a keyword. Okay, this is a keyword which I can use it with a variable, I can use it with a method, okay, I can use it with a class, and I can use it with a block as well. Got it? It's just a keyword. I can use it with a variable, method, okay, class as well as a block. Okay, but majorly in today's session, let us try to talk about variables and method. What happens if I have the variables and methods as static here? Okay, for example, okay, let me show it to you practically over here. Okay, imagine guys, I have a beautiful class here. See, I have a class, and imagine the class name is student. Okay, what is the class name? The class name is student. Open curly braces and close curly braces. Got it? So class is a platform to store the states and behaviors of an object, and the class name I am considering as student here. Now here in this respective class, I will have one variable. See here, int, okay, int, for example, age equals to 10. As of now, it's a static variable or a non-static variable. You'll tell, sir, it's a non-static variable. Why? Because we have not specified the keyword called as static. So therefore, I specify the keyword called as static. Now, is it a static variable or non-static variable? Now, it is a static variable. So in student class, we have a static variable called as age here. Similarly, can I have one method also? Huh, absolutely, you can have one method also. How will you have? See here, void is the return type, indicating the method will not return anything. Study is the method name. Okay, open parenthesis close and open curly braces close here. This is the scope of the study method. And I just give one line of implementation, that is system.out.println. I just give it as studying over here. I just give it as what? I just give it as studying over here. Now, as of now, is it a static method or a non-static method? Sir, it's a non-static method because we have not made use of the keyword called as static. Now, when I make use of the keyword called as static, is it a static method or non-static method? Now it's a static method. Why? Because we have defined the method with the help of a keyword called as static. So in student class, okay, we have two static properties, two static members. Okay, that is one static variable, one static method. Okay, now done everyone here. Okay, after this, okay, where will the execution always begin from? The execution will always begin from something called as main method. Correct? The execution will always start from where? Main method. Public static void main string array of arguments, and then open curly braces, close curly braces. Okay. So now what is happening over here? When I execute the class, okay, when I execute the class, meaning when I execute the program here, the execution will always start from the main method. Okay, but internally there is a person. and that person name is called as class loader. What is that person's name? That person's name is called as class loader. What he will do here, as soon as I execute the class here, as soon as I execute the program here, the person by the name class loader will load all the static properties inside a memory location called as a class area. Meaning there is one memory location. Okay, now see, this is the memory location, imagine. Okay, and what is this memory location name called as? This memory location name is called as, okay, class area, or we also call it as static pool. Class area, or we also call it as static pool here. Okay, so what happens? And automatically the name of the static pool will be the class name. So what is the class name? Student. So the static area name will be student here. Okay, got the clarity here? I'll repeat, okay, don't worry, in order to understand this topic, it will take time. See, when I execute the program, okay, the execution always starts from main method, agreed. But internally, there is a person called as class loader. What he does, he checks are there any static properties into my class. If there are any static properties into my class, he is automatically loading, by default he's loading inside a memory location called as class area or static pool. And the name of the class area is automatically the class name. So what is the static property do we have here? We have age. So age will get initialized to the value called as 10 here. And again we have one static method also, that is study method. Again, the study method, okay, will be pointing to some memory location 0x1, wherein the 0x1 will be storing some implementation, that is SOP, studying here. Okay, so this is what we are supposed to understand over here. It is pointing to some address here, okay, and that address is storing the content here. Okay, let me show it to you. Okay, this is all about it. Got the clarity here? So this is study method, okay, and study method is pointing to some address 0x1, and this 0x1 is storing the implementation of that respective method here. Got it? Done. So now here, if I want to access the static properties here, I have to always access it with the help of class name. Why? Because all the static properties are loaded inside a memory location called as class area or static pool, and the name of the class area is automatically the class name. Therefore, in order to access the static properties, I have to always make use of class name. Therefore, in order to print the static variable age, I have to make use of the class name. What is the class name? Student. Student dot, what is the variable name? It is age. So I have to tell student dot age. When I tell student dot age, what is the output I get? I get the output as 10 here. Similarly, if I want to call the method, I have to make use of class name, that is student dot, what is the method name? Study method. I call the method. So when I call student dot study method, the study method will get invoked and I will get the output as studying here. Okay. So if it is non-static, you have to create an object. If it is static, you have to access it with the help of class name. Okay. But static properties, if you want to access it in the same class, you can do it directly as well. So you will simply write it as, okay, you will simply write it as age over here. But internally, it will consider as class name dot age only automatically. So I'll get the output as 10 only. Again, in order to call the method, I can directly call the method as study method. Internally, it will consider as what? Class name dot study method. So I'll get the output as studying again. So in simple terms here, okay, static properties, it has to be accessed with the help of class name. But now do not worry, until and unless I complete the session here, you'll not have the complete clarity. Wait for it, okay? So these are all the beginning stages, okay? I know, I mean, sir, what is happening, sir? You'll have this thing because I'm doing this topic from a several years here. I know what are the perspective of students here, okay? But yeah, wait for it, okay? What is the first point here? What is the first point? Read out. The first point states static is a keyword which can be used with a class, variable, method, and blocks here. So static is just a keyword. Keyword meaning it is already predefined. Okay, it is compiler known word or reserved word. So static meaning it's a predefined keyword. Okay, which I can use it with a class, variable, method, and block here. Okay, when I execute the Java program, okay, there is a person. What is that person name? That person is called as class loader. Okay, when I execute my Java program, internally there is a person called as class loader. What he does, he loads all the static properties, whatever we have, or everything inside a memory location called as class area or static pool. So I told you, right? Non-static meaning you have to explicitly create an object and allocate memory. But if it is static here, you know what happens? Automatically there is a person called as class loader. He will automatically load, okay, meaning store all the non-static properties inside a memory location called as class area or static pool. Okay. And if at all you have static properties, you have to always access it with the help of class name. Static meaning you have to always access it with the help of class name here. Okay. So now if there are static properties, you can access, directly or with the help of class name in the same class. That's what I showed it to you now. If we have static properties, we can access it directly or with the help of class name within the same class. Okay. But outside the class, you can access it only with the help of class name. You cannot have any other choice here. Okay. You have to always access it with the help of class name. And have also given you the syntax as well. What is it? Class name dot variable name and class name dot method name of. That's how we need to access the static properties. Okay. Do not worry about anything. We will talk everything in detail. Okay. So now just talk about one example over here. I go back to my program to work around with Eclipse here. Okay, it's a three-step process, right? What is it? Project, package, and class here. So let me create a beautiful project here. Okay, what is this here? Let me create here project here. Okay, file. You can click on new. Okay, and then I am supposed to, create a Java project. Okay, and my Java project name will be, I'll just give it as static keyword. Okay, and the Java project name is static keyword. Okay, got the clarity here. Okay, now done. So now over here, after this entire process is done over here, okay, project got created. Now I need to create a package. In order to create a package, the shortcut key is Control N. When I tell Control N, I have to create a package, and the package name is com. Okay, so project got created and package got created here, and then here we have to create a class here. Okay, Control N again. Control N, the new tab will appear, and I will search for something called as class, and I'll give the class name as student here. Okay, I'll give what the class name as student. I'm done with this. Okay, so beautifully you will definitely get the class here. So the first line states package com. As I told you, package com meaning there is a folder by the name called as com. Okay. Public is the access specifier. If a class is public, it means everyone can access it. Okay. And and what do you mean by class? It's a blueprint of an object, meaning it's a platform to store the states and behaviors of an object here. Okay. And what is the student name? Class name. The class name is student here. Okay, now here after this entire process is done over here, okay, now what I'll do, I will have a variable. See, int age equals to 20. Now tell me here, okay, is this a non-static variable or a static variable? Sir, we are not blind, sir. Okay, therefore there is no static keyword use. It's a non-static variable. But as soon as I specify static keyword, it behaves as a static variable. So as soon as the font also changed. Can you see? If you could closely observe on age, as soon as I remove the static here, look at the font, what will happen? It's a bit bold, right? But as soon as I make it a static here, can you see the font will change automatically? Correct. So that's what I'm telling here, okay? The font style will change. Okay, it's a static variable. Similarly, I will have a method. See, void is the return type. study is the method name, open parenthesis close, and open curly braces close. Okay, and I'll just give the implementation as sys out. I'll just give it as student is studying here. Okay, I'll just write it as student is studying over here. Okay, I just give it the output as student is studying. Now, is it a static method or a non-static method? So there's no static keyword used, so therefore it is non-static method. But as soon as see here, look at the font style now, it's study. As soon as I make it a static, look what happens here. As soon as I make it a static here, it's same. Now it doesn't change. Okay. But what is static over here? It's a static method. Now in my entire program over here, there are two static properties, one static variable age and one static method study. Okay. Now here, where will my execution always start from? My execution will always start from the main method. Correct? Main method is the entry point or the beginning point of my Java program. Okay, now for my understanding, I just write it as start at the beginning and end at the last here. Okay, done. Now here, what am I supposed to do here? Guys, see, when I execute my Java program, right? Okay, when I execute my Java program, internally what happens here? The person by the name called as class loader will load the class, meaning he will store all the static properties inside a memory location called as class area. And the name of the class area is automatically the class name. So therefore, if I want to access the static variables, okay, we have to always access it with the help of class name. That is student. Okay, student dot, what is the variable name? It is age here. And if I want to access the method also, I have to make use of student dot study method. So static property should always be accessed with the help of class name, because static belongs to the class, not the object. Okay. So now when I execute it, look at the output what I get here. Start, okay, 20, student is studying, and end. That should be my expected output. Did I get the output here? Start, 20, student is studying, end here. Similarly, okay, similarly, if you are trying to access static properties in the same class, we can access it directly as well. That is, if you want to print the age here, you can directly write it as age. It won't give an error. But internally, it will consider as the class name, the current class name dot variable name. This is what it is going to consider internally. So internally, it's like what? What is the class name? It is student. Student dot age will automatically get printed here. Okay, so this is what is happening internally. Even when I try to print the data directly over here, it will consider as class name dot the variable name, that is age here. So internally it will print this data here. Similarly, if I call the method over here, okay, if I call the method called as what? Study method, I can call it directly. Even yesterday I told you how do we call main method directly. So this is what is happening. So it is nothing but class name dot method name of. Okay, so class name dot method name of, and what is the method name? It's study method, and student dot study method would get called here. Got it? So now when I execute it, if you want to remove the start and end, remove it. It doesn't matter. Okay, you can remove the start and end. But ultimately, static properties have to be accessed with the help of class name or directly within the same class. Okay, this is the final goal here. Okay, so let me write the comment over here. This is nothing but accessing static properties within the same class. Okay, this is all about the entire process. But what is the difference? Everything I'll tell you later, guys. I'll tell everything later. But as of now, we are just trying to check, okay, if at all I have a static variable and method, how do I access it within the same class? How do I, print it or call the method in the same class? Either with the help of class name or directly, you can do any of these. Okay. But similarly over here, I'll have one more class. See, Control N is the shortcut key to create a new class. Okay. And the new class name is, imagine it is employee. What is the class name? The class name is employee. Okay. Now I have a beautiful class called as employee. In this class, it will have one variable. Int id equals to 101. Okay. Static variable or non-static variable? Sir, as of now, it is non-static. Very good. Now I have to make it as static. How will I make it as static? Sir, just specify the keyword called as static. Just declare the keyword called as static. Now it will behave as a static variable. Done? Similarly, I will have one method. Work is the method name, open parenthesis close, and here I'll just write the implementation as employee is working. Okay, I'll just write it as employee is working. What is missing right now? The return type. So the return type will be void. Done. It's a static method or non-static method. As of now, say non-static method. How will I make it as a static method? I have to make use of a keyword called as static. So in my employee class, okay, I have one static variable and I have one static method. The variable name is id and the method name is work method. Okay. Now here I want to access static properties outside the class, meaning in some other class here. I'll create one more class. See, control N. I will create a class and the class name is test here. Okay, what is the class name? Test. So I'll just drag it towards the right side here. Okay, I'll just drag it towards the right side over here. Okay, perfect. Okay, so this is an example for accessing static properties in another class. Okay, in another class. Okay, this is an example for it. Okay, now I have my main method. Now here, this is wherein the execution will always begin from. Correct? So now when I execute the program, right, when I execute the program here, this, the class loader will have loaded all these classes here. Now when I try to access this variable, see, now when I try to print it, I will access it with the help of class name. See, class name is employee dot, what is the variable name? ID. So whenever you have the static variable, you will always access it with the help of class name. Correct? So see, employee.id. And similarly, in order to access it, I'll tell employee.work method. So when I tell employee.work method, I am able to access it. What if I directly access it here? See, if I directly tell ID here, it will give an error. Why? Because internally it will consider as class name.id. So which is the current class which is getting executed? Test. So it will internally consider as test.id. But there is no variable called as, there is no variable called as id in test class. Therefore it gives an error. Similarly, if I try to call the work method directly here, it will give an error. Internally, it will consider as the current class name which I'm executing is test.work method, wherein the work method is not there in test class. Therefore, I get an error here. Got it? So in simple terms, what did you understand here? Static properties in the same class can be accessed directly or with the help of class name. Okay. But static properties outside the class here, we have to always make use of the class name here. We cannot access it directly. Okay, so this is the difference between accessing static properties. So once when I executed, did I get the expected output 101 employees working? Yes, it's simple. Okay, we know how do we write a variable and method, but we're just trying to understand what is static, what is the functionality about static here. Got it here? Understood everyone over here? Okay, so now this is what I have written in the document here. So the first 5 points which I have is all about what I have explained now. Okay, meaning it's a keyword which we can use it with a class, variable, method, and blocks here. Okay, so once we execute a class Java program, no, the class loader will check, oh, is there any static property? If there is any static property, he will automatically load it within a memory location called as class area or static pool. And you have, generally speaking, static properties will be accessed with the help of class name. If it's in the same class, either directly or with the help of class name, or if it's in another class, we will always make use of class name. We don't have any other choice, and I have given you the specific syntax as well. Okay, and what is the note here? I will talk about it a bit later. Okay, the note here which I have at the bottom of the screen, I'll talk about it a bit later. But now here, the most important point for us to understand is the major difference between them. Okay, what is the major difference, sir? That is what we are supposed to understand here. Okay, so let me draw a small table for you all so that I can give you an elaborate differentiation between these terminologies over here. Okay, between everything, I'm just going to give you a lot of differentiation here so that it would become very easy for your understanding perspective here. Okay, so now here I'm just drawing a small table. Okay, so wherein we are going to understand the difference between static and non-static so that you'll have the clarity about this entire topic here. Okay, so let me just shape it out. Okay, accessing in another class. Okay, so yeah, last table, last block. So we would be done with it. Okay, great. We're done with this entire process, guys. Okay, now here there are how many types, of variables here? We have two types. One is static, okay, and another one is non-static. So we just need to understand what is static and non-static here. So what is the first part here? How do you access, okay, static properties in same class? Accessing in same class. How does it happen? Done. Similarly, accessing in another class. Okay, how does it happen here? Accessing in another class. How does it happen? Then the memory location. Okay, we can do it in orange here. The memory location. How does it work here? Okay, and the last part is number of copies the static properties and non-static properties will have. Okay, so it's very important point, guys, so just concentrate here. Okay, see here, if you have static properties, okay, it can either be a variable or method. If you have static properties, if it's either variable or method, you can access it with the help of class name. You can access it either directly, okay, or with the help of class name within the same class. If you have static properties here, how do you access it within the same class? Either directly or with the help of class name, right? In another class that you don't have any other choice, you have to always make use of class name. Done? But if it is non-static, okay, it doesn't matter if it's in the same class or another class, you have to blindly create an object. Okay, always we have to always create an object. Got the clarity? In simple terms, static belongs to the class, non-static belongs to the object. I repeat, static belongs to the class and non-static belongs to the object here. Okay, and then in which memory location, okay, does the static properties get loaded? The static properties will always get loaded inside a memory location. Okay, you know what is that memory location called as? That memory location is called as class area, or we also call it as static pool. Okay, static pool. And non-static properties are, we need to create an object to allocate the memory, and the objects will always get stored inside a memory location called as heap area. Static properties will get loaded inside class area, and non-static will get stored inside something called as heap area. And I will talk about the memory architecture probably in coming days. Okay, and now here, this is the major difference here which we are supposed to understand. Okay, sir, how many copies will static have? Okay, irrespective of how many ever objects we create, static properties will only have one copy per class. Okay, only one copy per class here. Okay, this is what we are supposed to understand. This is a very important point. Static properties will always have only one copy irrespective of how many ever objects you create. But whenever we talk about non-static here, it depends on, okay, depends on number of objects created, number of objects created. Okay, so this is what we are supposed to understand here. Got the clarity here? But can you explain the last point, sir? Absolutely, I will do it for you. Now, imagine, okay? I want the importance of understanding this, okay? So everyone try to understand the program. See here, I will have a class and the class name is demo, okay? What is the class name? The class name is demo here. And inside the demo class, I will have two variables. Okay. See, closely observe here that I'll have two variables. Static, okay. Static int, okay. X equals to 10. It is a static variable, correct? And I'll also have a non-static variable. Int y equals to 20. So inside my demo class here, okay, inside my demo class here, I have two variables here. One is a static variable x, another one is a non-static variable y. Okay, once I execute the Java program here, okay, once I execute the Java program here, there is a memory location. Okay, what is that memory location called as? That memory location is called as class area. Okay, or we also call it as what? We also call it as static pool. Okay, there is a memory location called as class area or static pool. Within that memory location, this static variable x will get loaded. So this x will get loaded to the, in within the class area or static pool. And the name of this class area is automatically the class name. So the name of the class area will become demo here. Got it? So what happened here? Once we execute the class, the person by the name called as class loader will automatically load the static properties inside a memory location called as class area. But now, non-static property, did it get loaded? No. Non-static properties will get loaded only when we create an object. Okay. So now when I create one object, demo d1 equals to new demo of. So now here what is happening? Now when I create an guys go on mute. Thank you. So when I tell new here, internally an object is getting created. What is happening here? One object is getting created with the address 111. And who is pointing to that object? D1 is pointing to that respective object here. Okay. And the non-static property should get loaded now. So which is the non-static property? Y. Y will get loaded to 20 because non-static properties will get loaded only when we create an object. Okay. Similarly, I will create one more object. Demo d2 equals to new demo of. I create one more object. Now what is happening? New meaning one object is getting created. New meaning what is happening? One object is getting created with the address 222 and d2 is pointing to that respective object. Okay na? And then the non-static variable y has to get loaded within the object here. So the number of times the non-static properties are loaded is dependent on how many objects I have created. If I have created 10 objects, 10 times it will get loaded within the memory. But static properties, irrespective of whatever happens, it will get loaded only once within the memory. Okay. Similarly, let me create one more last object here, that is demo d3 equals to new demo of. I have created an last object over here. Once I'm done creating that respective object over here, what happens over here? Okay, again one more new object will get created. Okay, and the address of that object is 333 and d3 is pointing to that respective object. See, new meaning object got created with address 333 and d3 is meaning it is pointing over there. Again the non-static property y should get loaded to 20. So therefore, okay, static properties will have only one copy per class and non-static properties will have multiple copies based on the number of objects we create here. Got the clarity here? and objects are all created inside a memory location called as heap area. Okay, the objects are created inside a memory location called as heap area, and the static properties are loaded inside a memory location called as class area or static pool. Got it? So this is what I told over here. Okay, so whenever you have static properties, okay, you will access it directly or with the help of class name within the same class. Okay, static properties outside the class here, always class name. Static belongs to the class, and non-static, it is always object creation. Irrespective of same class or another class, blindly create an object always. Got the clarity here? Okay, now understood. This is static, this is non-static. Done. And then which memory location? Static properties, class area. Non-static properties, heap area. And static properties will have only one copy, and here it will depend on number of objects we created. Multiple copies based on number of objects we created here. Got it? So this is the basic understanding about static and non-static here. Okay, but now I will tell you when do we choose what here. Okay, when do we go for static and when do we go for non-static? I will tell you in a beautiful manner here. Okay, so this is what we are supposed to understand here. Okay, now, so now I had one note over here, right? Okay, what was that note here? Static properties are loaded only once. Therefore, they will have a single copy. Meaning they are loaded only once, right? So 101% here, it will always have a single copy here. And there is one more point here. Okay, what is it? All the objects will implicitly be pointing to the static pool. Okay, therefore, we can access static properties with the help of object reference, but it's not a good practice. Okay, what does it mean? What does it mean? I will tell you here. Once you know what happened over here, this is the static pool, correct? And each and every object will be internally pointing to the static pool. It will be internally having the access to the static pool here. But it's not a good practice to access the static properties with the help of object creation here. Okay, now, for example, look here what will happen over here. Okay, look here what will happen. I will create a class called as, okay, car. Okay, I will create a class called as car. Open curly braces, close. Right? Done, everyone? Now here, when I tell static, okay, static int cost equals to 10 here. What have I done? I have created a class called as car, and then what have I done? I have a static variable called as cost that is initialized to 10 here. And I will have my main method wherein the execution will always begin from. Okay, so now here when I execute the Java program, okay, internally a person by the name called as class loader will load all the class here, okay, will store all the static properties inside a memory location, and that memory location name is car. Why? Because the static pool name is, or the class area name is automatically the class name, and the cost will get initialized to 10 here. It will get initialized to what? 10 here. Now if I want to print it, okay, I will tell system.out.println. I have to access it with the help of class name or directly because it's within the same class. So I'll tell car.cost here. What is car.cost here? When I tell car.cost here, I will get the value as 10. So let us cross check. Let us cross check. See, I will create a Java program. Okay, just a moment. Oh, yeah, perfect. See here, control N, and I will create a class, and the class name is car here. Okay, now, and here I will have one static variable. See, int cost equals to 10. Is it a static variable or non-static? It is absolutely non-static as of now, but I'll make it a static. Okay, done. And I'll have my main method. Okay, main method is wherein the execution always starts from. So when I execute my Java program, the execution starts from my main method, but by the person name called as class loader will load all the static properties within the class area, and the name of the class area is by default the class name. So therefore, if I want to access the variable here, I will write it as car.cost here, car.cost here. Okay now, so what will be the expected output here? It should be 10. Did I get the output as 10 here? Yes. This is what I told you in this respective program. I'll get the output as 10. Now there is one mindset. Okay. In engineering, when I was there, even I got confused over here. They told static properties cannot be reinitialized. We had that part. It's a constant. Never ever go wrong here. Okay. That's a very, very misconception you all have. Misunderstanding. Okay. Static variables can be reinitialized. Okay. Now, so I will easily tell car dot cost equals to 20. So when I tell car dot cost here, this 20 is getting stored into a variable cost of the car class, meaning it's a static variable, right? So I'm accessing with the help of car here. So car dot cost will get reinitialized to the value called as 20. So therefore, now when I try to print system dot out dot println, okay, when I try to print the data here, I will be able to get, see, car dot cost. When I tell car dot cost, what is the value here? So when I tell car dot cost, the value is 20. So therefore, see here, I will reinitialize it here. Car dot cost equals to 20. And here when I try to print it, see, car dot cost here. So when I execute, first it will be 10 and then it will be 20. See, first it was 10, okay, initially, and then later it is 20. Got the clarity over here? But since we are trying to work with the static variable in the same class, we can access it directly also. See, I'll access it directly here. It doesn't matter. I will absolutely get the same output. See, when I execute, am I getting the same output? Why? Because it's static. Static in the same class can be accessed directly or with the help of class name. You could also tell, okay, car dot cost. It doesn't matter. Again, you could also tell car dot cost equals to 20. It doesn't matter at all. Okay, again, while printing it, you tell car dot cost. It doesn't matter. Why? Because it's ultimately static. Static in the same class can be accessed directly or with the help of class name within the same class. But if you try to access it outside the class, it becomes mandatory to access it with the help of class name. In the same class, you do however you want, but outside the class, it is always with the help of class name. But non-static, no differentiation. Same class also create an object, outside the class also create an object. Only one way you have. Okay, that's the thing. But the thing which I wanted to tell over here is, this is done. This is the first half. Okay, ignore it. But now here, when I create one object, see, car C1 equals to new car of, when I create an object, I can also access the static variable. See, C1 dot, I can also access the cost here. See, if I just hover on it, okay, it's telling the static field car dot cost should be accessed in a static way. So once when I create an object, what will happen, see, car C1 equals to new car of. I created one object, no. Now internally when I tell you, what will happen here? New meaning an object will get created. Okay. With the address what? With the address 111. And who is pointing to that object? C1 is pointing to that object. Are there any non-static properties within my class? No. I will store nothing over here. And this this object will be internally pointing to the static pool. It will have access to the static pool. So when I tell C1 dot cost, I can access the properties of the static variable. Okay, I can access the static variable, but it's not a good practice. So now that is what, if I just hover on it, see, the static field car dot cost, meaning cost is a static attribute. It's a static variable that try to access it in a static way only. But it's possible to access the static variable with the help of object reference here, but it's not a good practice. Okay, this is not a good practice. Okay, not a good practice here. Got the clarity? So this is the last point. See, all the objects will implicitly be pointing to the static pool. So therefore, we can access static properties with object reference, but it's not a good practice. So static belongs to the class, access it with the help of class name. Non-static belongs to the object, create an object and then access it. I repeat, static belongs to the class, and access it with the help of class name. Non-static belongs to the object. So create an object and access it. Non-static will have multiple copies and static will have only one copy. Clear? So this is all about static and non-static. Okay. I hope I have given you the complete clarification about what is static and non-static, right? So now there are a few questions here. I'll be answering to all your questions, but if you have any questions, you can let me know. Okay, the first question is, how do we send our assignments, sir? Okay, so assignments can be mailed to me. Okay, you can mail the assignment, or you can just take the snapshot and just drop a pic to through WhatsApp here. Okay, however possible here you can do it. Okay, you can send me through WhatsApp also, or you can just send me an email as well. Okay, it's possible. So there's one more question. Okay, so when we execute the program test, okay, first the class loader finds out all the classes which are referred in every program and loads them first. Very good question, actually speaking. Okay, so what was the question? No, very good question. So guys, there was one question here. See, there is one test class and there is one employee class. Correct? This was the class here. So now here I am accessing static properties in outside the class. See, employee is one class and it is having two static properties, that is ID and the work method. Correct? So now here when I execute the respective class here, okay, when I execute the respective class here, what are the classes present in that respective packages? Car, employee, student, test. All the static properties of those classes will get loaded. Meaning they both are present in the same package, no? They both are present in the same folder. So therefore, it will all get loaded here. Okay. So that is the question which I asked, right? Okay. Sir, when does it get loaded here? Correct. When does the class get loaded? In simple terms here, when you are accessing the static property, immediately the respective class will get loaded. Okay. That's one way of understanding here. If not, all the classes are present in COM package, correct? So all the static properties in that respective packages will get loaded here. Okay, so I hope you got the clarity now, right? So any other questions apart from this, guys? Any questions? Quickly answer. Any questions, anyone? Okay, there's one question. What if a class is declared as static? Actually speaking, okay, a class directly cannot be static. See, as soon as I write it as static here, it will give me an error. Why? Because see, illegal modifier for class public. Only public and abstract final are removed. So a static class, a static can be a class, but it cannot be an outer class. For example, wait, I'll give you the clarity. Control N, I create a class called as A. Okay, now see here, this is called a static class, correct? It's giving an error because we cannot have a static outer class. But now we can have something called as nested class inside a class. Okay, so this is a class inside a class, nested class. Correct? We know what is nested if, no? One if is present inside another if here. Similarly, we have a concept called as nested class. Okay, so an inner class can be static. See, class B can be static because it's the nested class, inner class. Okay, but the outer class can never be static here. Okay, so that's the difference here. We can have, okay, static can be used for a variable, method, blocks and classes. Okay, but the outer class cannot be static, but the inner class can be static. Okay, so that's a different topic altogether. Okay, but have this thing in your mind. Okay, at the back of the mind, you have this point. Clear? Understood everyone? Guys, any questions in whatever discussed till now? Any questions? Quickly answer. Okay, there's one more question. What is a block? Okay, tomorrow you'll understand. Tomorrow topic is nothing but static and non-static blocks that you will understand in tomorrow's session. Okay, see, each and every topics are dependent. Okay, so I cannot do everything in a single day. So I'll be doing it in sequential way. Okay, blocks will be done later and inner classes also will be done later, not immediately. Okay, so perfect. Great guys. Okay, so now you'll have one question. Sir, you told static one copy, non-static multiple copies, blah 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 blah. You did a lot of things, no sir. But where do we actually use it here? Okay, I'll give you one scenario. Okay, I'll give you one scenario here. Okay, just observe. I will have a class called as student. Okay, I will have a class called as student over here, right? Now here, what I'll do, every student will have the name, correct? Or else will have every student will have the ID, correct? And every student will have the college name, okay, in which they are studying. Got the clarity, no? Everyone understood, right? I have a student class and there are two attributes, ID and the college name where they are studying. So, and they both are non-static. As soon as I tell non-static, oh, yes, yes, sir, object creation, sir. Okay. Now I will create one object. Okay. So I will create what? Student, okay, student S1 equals to new student of. I create one object. Now what happens here? S1 object will get created. What will happen here? S1 object will get created. ID will get loaded and the college will also get loaded. So what will I do? The ID is 101 and the college name is, imagine it is J Spiders. I'll write it as J Spiders. Correct? Similarly, I'll create one more object. Student S2 equals to new student of. So again, what will happen here? One more object will get created. Okay. And that object is nothing but S2. Okay. Again, since it is non-static, it will have multiple copies. Okay. So now here, ID is 102 because unique ID and college is the same college they are studying. Okay. That is J Spiders. Again, I'll create one more object. Okay. Student S3 equals to new student of. How many objects I created? Three objects I created here. Okay, now three objects I created. So this is S3 object. Again, ID and the college will get loaded. Okay, and the call ID is 103 and they're studying in the same college called as JSP. Got it. So now what did you understand over here? Don't you think so? There is a repetition here. Sir, student is a class and it had two non-static variables, that is the ID of the student and the college where the student is studying. So they both are non-static. So when I create three objects, those variables will get loaded three times. Okay, ID three times, college three times. ID is dependent on the student object, correct? Each and every student will have different IDs, correct? So ID should be non-static. Why? It will have multiple copies, multiple students. But ultimately, college is same, no? Why will you have multiple copies here? Correct. So make it as static. So make it as static here. So once you make it as static, I'll tell you what will be the solution. Okay, what will be the solution? I will show it over here. I will have a student class. Okay, I will have a student class. Student. Okay, in that student class, I will have the ID as non-static. Why? Because it is dependent on multiple objects. Because every student will not have the same ID. It is dependent on the object. So I'll make it as non-static. But the college, I'll make it as static because they're all studying in the same college. So one copy is sufficient. Correct? So as soon as I tell college is static, what happens here? There is a memory location. What is that memory location name? Class area. Okay, that is nothing but what? Class area. And that class area name is student. Okay, now here the college would get initialized to. Okay, the college would get initialized to JSP. Now if I create one object, see, if I create one object, student S1 equals to new student of. Okay. Now what happens here? S1 object will get created. Okay. Which object will get created? S1. And which is a non-static property? ID. ID will get, I will initialize to 101. But this will be initially pointing to the static pool where the college is JSP. Correct? Similarly, I will create one more object. Student S2 equals to new student of. I create one more object. So internally what will happen here? One more object will get created. Okay. And the, that is S2 object and the ID will get initialized to 102. And this will internally be pointing to the static pool also where the college is JSP, which is defined only once. Okay. Again, I'll create one more object. Student S3 equals to new student of. Okay. So what happens here? One more object will get created, that is S3, right? And then internally what will happen here? The non-static property ID will get initialized to 103 and it will be pointing to the same copy, that is college equals to JSP. So in the first program, what happened here? Sir, ID and college were non-static. So you have to define it multiple times. You have to define it multiple times and initialize it multiple times. Okay, all the students are working for the same college here. That is J spiders, J spiders, J spiders. In order to avoid that redundancy, what I'll do here is I will make the ID as non-static because it is dependent on the student objects. But college is static because one copy is sufficient enough. No. So I'll create three objects wherein the IDs are different, wherein they are all pointing to the same copy, that is J spiders. So that way, whenever there is requirement for a single copy, it is static. Whenever there is a requirement for multiple copies, it is non-static. Okay, so this is what we are supposed to understand with respect to real time. Got it? I hope we all understood what is static in a beautiful manner. Correct? So what is static basically, guys? It's just a keyword which we can use it with a class, variable, method, and blocks. Now we understood what is a static variable, static method. That's it. Okay. And when we execute a class, once we execute a Java program, the class loader will automatically, implicitly load all the static properties inside a memory location called as class area. And static belongs to the class. Therefore, we have to access it with the help of class name. Okay. And static properties, irrespective of how many ever objects you created, if you create, only one copy will be there. And all the objects will be pointing implicitly to the static pool here. So therefore, this is what we are supposed to understand. And I have given you the major differences as well. How do we access the static properties? Okay, so this is all about static and non-static, guys. Okay, so anyone having any confusion till whatever I did now? Okay, we are actually done with static now. Okay, anyone having any confusions? I want answers from everyone here. Any confusions here? Okay, so any questions? I have one question, I'll answer. No, right? Okay, perfect. Very good, guys. Very good. Okay. So there is one question here. There is one question, that is methods should be ideally declared as static. Okay, there is one question. Okay. Should methods be declared as static here? No. I'll tell you one way. So whatever you asked is again a valid question here. So now imagine, okay. Now imagine there are there is a developer, okay. There is a tester, okay, and there is an HR, okay. So everyone will have work method, okay. Everyone will have work method, correct. So now tell me, okay, is developer, tester, HR work is the same or is it different here? It is different, obviously. The work of the developer is to develop an application, blah 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 blah. The work of the tester is to test an application, and the work of the HR is to recruit. Okay, imagine it is to recruit. So again over here, it is the work method is dependent on the object here. Okay, if the tester is working, his work is different. If the developer is working, his work is different. If the accountant is working, his work is different. If the prime minister is working, his work is different. So we want multiple copies because there are multiple different working functionalities here. Again, it depends when you go for static, when do you go for non-static. You have to just understand this requirement here. Okay, so that way it becomes easy to understand here. Okay, and another way is to save memory also, you can tell. Okay, to save, because why do you involve multiple copies here? Okay, if it is necessary, you utilize it. If it is not necessary, have a single copy. Okay, that way. Got the clarity now? Okay, I hope everything is cleared now. Okay. Great, great guys. Okay, so I had given one assignment yesterday, right? Okay, how do you check if a number is positive or negative, correct? So let me do this similar kind of a program for even or odd. Okay, so just understand the program, guys. Okay, just understand the program here. Okay, I will have a class, a class called as demo class. Okay, I'll have the class called as demo class. In the demo class, okay, I will have one method. See, the method name is check even or odd here. What is the method name? Check even or odd, open parenthesis close, open curly braces close here. Okay, now that's it. Now here, what is the return type? I don't want to return anything, so I'll just make it as void. Don't relate static and non-static now. It's just a programming question. Okay, don't relate it's a static or non-static. No, it's just a simple program. That's it. Okay. Now here, this will accept a variable called as n. So what will be the logic here? If n mod 2, if it's equal to 0, we all know that, right? If the number is completely divisible by 2, it is even number. If it is not divisible by 2, it's an odd number. So here I'll just write the logic as n, okay, is a even number. Okay, 2 is a even number. Else, okay, I can just write it as sys out, okay, n plus is a odd number. Okay, this is all about it. Got the clarity here? I'm just making use of curly braces in the same line. If you don't like it, you can ignore it. Okay, as I told you here, you can make use of the logic wherever you wish to. Correct? And here I will create one more class called as solution class. Okay, what is the class name? The class name is solution class. Inside the solution class, what are we doing here? First of all, I will have my main method wherein the execution will always begin from. First of all, check even or odd is a non-static method present in demo class. So what am I supposed to do? I have to blindly create an object because it's a non-static method. And now I want to accept dynamic input from the user and call the method. So I can also create an object of scanner. Scanner scan equals to new scanner of. I created an object of scanner and I pass system.in. Two rules done, and I have to import the scanner class as well. Okay, now here I will tell sys out enter number. Okay, and that number I will store it into a variable called as scan.nextEnd, and I have to call the method d.check even or odd here, and I pass that number over here. Okay, this is all about it. So now when I execute my program, okay, just observe the output what I get here. So just observe the output what I get here. Enter number 10. So 10 is a even number. Okay, but I want to repeat this process for several times here. That's the reason here I will have one int I equals to 1, I should be lesser than or equal to 4, I plus plus, meaning my loop is working for 4 times. Okay, my loop is working for how many times here? It is working for 4 times. And what am I supposed to repeat here? I am supposed to repeat this entire topic here 4 times. See, now when I execute it over here, enter number 2, even number 3, odd number 4, even number 5, odd number. So 4 times, because the loop went for 4 times, 4 times it is done the job and it stopped. And at the last you can tell, right, once you're done accepting the input, you can tell scan.close. So once I tell scan.close, it means I'm done with accepting the input. Please close the resource here. That's all about it. This is what I told. You had to do it for positive or negative. Again, you have to tell if the number is greater than 0, it will become positive or negative. That's all about it. So you will have a class, you will have a method here, and that method you will write the logic, the business logic to check if a number is even or odd. Now in another class, you'll create an object of scanner because you want to accept dynamic input, and you'll create an object of demo because you want to call that check even or odd. So this loop will work for 4 times. Enter number, you will accept the number, store it into a variable called as num. Okay. After that, you will call the method. You will call the method, check if it's an even number or odd number, comes back, this line will get printed, again goes back. 2, 3, 4. So 4 times this process is repeating over here. So that's why you get this expected output here. Okay. So this is all about, okay, the nature of, okay, how the program is going to work like. Okay. I hope you all got the clarity about this entire topic here. Okay. This is what I expected, from yesterday's topic whichever I have told. Okay, so done guys. Okay, so we're pretty much done with the session here. Okay, so we are done with static. Okay, non-static, we also understood a lot many topics here. Okay, so tomorrow the topic which I shall be discussing is blocks. Okay, there is something called as blocks, that is nothing but static and non-static. So what are those blocks here? We will try to understand in tomorrow's session. Clear? Perfect guys. Okay, so we're done with the session here. Okay, so anyone having any questions here? Anyone having any questions here guys? Okay, assignment I'll forward it. I forgot last yesterday or day before yesterday. I'll send it to you. Assignment. Okay, in the group I'll forward it. Okay, great. Any questions, guys? Anyone apart from doing assignments? Okay, great, guys. Okay, perfect, perfect. Okay, so great then. Okay, so we shall wind up a session for today. Okay, and catch up tomorrow. Okay, so thank you all. Take care. Bye bye. Have a nice day.